And then I'm going to share my screen. Okay, so the first question that we're going to be looking at is one that deals with 3 charges around each other. Okay, so with these 3 charges around each other, I'm going to draw them on the ends of a triangle, but please note the triangle itself doesn't exist. So this could just be a triangle that I drew on a piece of paper, or you could just accept that I've got charges 1, 2, and 3. So Q1, Q2, Q3 on the, I'm going to call them apexes rather than corners of an equilateral triangle. That idea of equilateral triangle is very important. The other thing that I'm just going to throw in here to make this a little bit easier is that this bottom line here between Q1 and Q2 is a horizontal, okay? And I'm not going to give you the values. I could choose any values I like, but I'm just going to randomly pick them. So this is plus 3 millicoulombs, this is negative 6 millicoulombs, and this is plus 4 millicoulombs. And your question is to determine the resultant force acting on Q1. So I want to know, what is the resultant force acting on this charge? Now, I know I mentioned to you that this question came from a tutorial for first-year med students. However, it's not beyond the scope of the curriculum that they can ask you this question. However, this question links a lot of your knowledge about how to work with forces, so kind of your Newton's law type questions. I guess if I wanted to be even more challenging, I could tell you what the mass of this charge is and ask you to work out the acceleration, but that would be the suicidal question of the particular assessment. So our question is to determine the resultant force acting on Q. I'm going to quickly stop sharing for just a second. Can I suggest that before I do, you quickly take a screenshot so you've got something to look at while I'm talking to you? So I want to actually be able to see all of you while I'm discussing this. Okay, so I hope everyone's got that. Okay, so my first question, and please, this is your opportunity here to speak up, is does anyone have an idea of where they would start? You don't have to tell us the solution yet, but where would you start with that question?
Okay, I'll try.
Actually, I lie. Before you do, where would you start if I gave you the full question? Because I didn't. Oops, that bit where you remember that you've forgotten a bit. The length of a side is 5 centimeters. There we go. Now I can say we can start. All right, the problem with my memory. Yes, okay, who was offering an answer?
Me, Kim.
Okay, yes, Kim, hi. What do you think you'd do?
The first thing I would do is figure out the attractive and repulsive forces. And
okay,
then
so you'd work out which way the forces were. Okay, yeah.
And then also take note that all the sides would be 5 centimeters.
Okay, so you've got your distances. Why is it important to have your distances?
Because we need it for the calculations.
Okay, and which calculation are you planning on using?
What's the name of it? The E.
Coulomb's law. You're not working out.
Okay, yeah.
You're not working out the field here. You're just working out Coulomb's law. So you're just working out forces. Please make sure that all of you know when you're doing forces and when you're doing electric field at a point, because they're 2 totally different equations and they cause lots of issues. That sounds like a good approach. So I'd apply Coulomb's law. How many times are you going to apply Coulomb's law?
Twice.
Twice. Once for each of the charge 2 and the charge 3. Okay, so that sounds like a very good idea. The next thing that I want to just quickly check from you is, has anyone yet worked out what the angles inside the triangle would be?
60.
Yeah.
Okay, so the fact that they told you it was an equilateral triangle, they assumed that you were smart enough to figure out that that meant that you knew that there was a 60 degree in there. Okay, now going back to the question, just quickly while I'm looking at you, I've just seen there's a question on the chat. Sorry, ma'am, was it an equilateral triangle? Yes, it was. Okay, so going back to the question, who feels like they'd be able to make a good go of this question? From all the practice that you've done, you'd at least be able to work out the force due to the first charge, the force due to the second charge, and then maybe start on a diagram. So what I'm going to do, because I think it's so important for all of you to have this opportunity, is I have the ability to share my screen with you and then pause it, which means that I'm working it out while you're working it out. And what I'll do then is once I've finished and once all of you are sure you've got to the end, is I will share my screen with the solution on it and we can all see how we understand it. Does that make sense? Okay, I have no idea. I must be honest, I've never done a recording before. I don't know whether it's going to record me working or not. It'll be interesting. We'll see, but we can determine that later. They'll still get to see the answer at the end. All right, so I'm going to go back to sharing my whiteboard. I'm going to ask everybody to have a good go of trying to work this out. Okay, don't worry about the screenshot, Brandon. I do my working out on here. Okay, so everybody should be able to see that. And I'm now going to pause share so that you can no longer see me writing, but you'll see the original question. Okay, please, you've got to remember that at this point, I can only see myself. I can't see you. So if you have a question, you either need to speak up or you need to chat. I can see either of those. Okay, go for it. Okay, if you're done, you can just give me a thumbs up so that I know I've moved it so that I can see the full screen of everybody working. Okay, cool. I can see some of you are done. Now, I must confess, I haven't finished the full solutions because there's a bit that I need to work out with all of you. So at the moment, I've only worked out the two electric field strengths. Sorry, not the two electric field strengths, the two sets of forces, because I feel that the bit from there is where things get challenging. All right, so I want you to try and work further, but I want to work from where we've got all the forces onwards with everybody, just in case anyone missed the catches. Okay. Okay, that's more of you giving thumbs up. That looks good. Okay. All right, I'm not going to ask out loud. Is anyone still busy? Is there anyone? Please don't be afraid. I know sometimes people are always very self-conscious and they want to go, I don't want to be the one who says I'm taking longer. I think I've
I'm
given
still
you.
busy.
Okay,
I'm still
cool.
busy.
There you go, Alex. You got time. Don't stress. So I
I've
don't want
almost finished the question.
Don't stress. I don't want to rush you. The point is not to rush you. It's that I don't want you sitting here going, when is she going to start again? Or Kim, you're welcome to put the answer in scientific notation. Some bits of it get really big, but please, okay, you are allowed to round it up. I, however, wouldn't. Okay, because I don't want to lose any of the significance. Those are quite large forces for you to be going, oh, it's okay. Like, I don't know how many, 50,000 newtons doesn't matter anything. And I want to go 50,000 newtons could crush you. Okay, so I don't really want to make it something where okay, 50,000, but it's big. It's big enough that I don't want it on top of me. Okay, so don't round too much when it comes to scientific notation. Okay, is everybody done? Alex done?
Yes, whether it's correct or not, we'll see.
Don't stress, the same applies to mine. So we'll see. I can tell you I've got the right method. Whether I've got the right answer, that's another matter. Okay, so I'm going to start sharing my screen again, and hopefully I will not have made a mistake. Can I quickly check that everybody here got that the electrostatic force due to the Q2 charge, that's this one, was, and I've got to be careful, I'm going to do politician numbers, 64,800,000 newtons. Yes? And that the electrostatic force due to charge 3, that's this charge, is 43,200,000 newtons. Does anyone disagree with me? Yay, that's a good sign. Now, the next thing that I need to do is decide or determine which direction the force is acting. Now, the reason I didn't go any further than this is that if I showed you everything, you wouldn't be able to figure through the steps with me. So I think it's probably a better idea for us to do that. This is negative, this is positive. That means that Q1 would be attracted towards Q2, which means that its force is going to be upwards at that angle. Q3 is positive, Q1 is positive, so they're going to repel each other, so we will have a force that way. So we're going to have two forces acting at different angles, and my resultant is going to go somewhere in between them, which means if I drew a free body diagram, I would have a force this way and a force that way. In fact, we know how big those forces are. We know that this force over here is 64,800,000 newtons, and we know that this force is 43,200,000 newtons. Also, we know that this angle here is 60 degrees, and that could become relevant. Okay, so I'm going to leave it at this diagram for now, and I'm just going to check, has everybody taken a screenshot or got those answers down, F2 and F3, because I'm about to delete them. Okay, please also note in a test that you'd only have to write out the formula once. We don't give you multiple formula marks for every time you write it. It's a once-off thing. So if I drew the triangle of forces, okay, I would draw an answer here where I had 43,000, sorry, let's get that right. I'm going to change my method. Sorry, I was going to do this using a triangle, but I actually think I'm going to just do it using components. So what I'm going to do is I'm going to use the component method. I'm going to say, yes, I have 64,800,000 newtons. We've got an angle of 60 degrees. So we've got a force that acts, I'm going to call it vertical and horizontal. Technically, it's upish and to the rightish, but it doesn't really matter. Okay, it's not technically either of those, but this kind of will allow us to work out what the components are of this force in the directions that I'm talking about. Technically the X and the Y, but they could be a whole bunch of things. So if we carry on from here, I've got a, let's choose a pen color that isn't white. There we go. I've got opposite over hypotenuse here. So my FV will be 64,800,000. Okay, and then it's going to be sine 60. So 64,800,000 times sine 60 gives me a messy number of 5611844.6,17 newtons. Then I work out the horizontal, and this is going to be a cos because it's adjacent. So it's 64,800,000 cos 60. Some of you know your special angles, so you know that that gives you a half. Some of you aren't brave enough to put it in. There's nothing wrong with that. You're welcome to always put your calculator, well, to use your calculator properly. So here I got 32,400,000 newtons. Now, I personally redraw the diagram. I love physics diagrams because I can't work without them, but not everybody does. So the vertical component is 56,118,446,17 newtons. And then we have components. We have a force this way of 43,200,000 newtons and a force towards the right of 32,400,000 newtons. Okay, so what we now need to do is work out a resultant in the vertical direction and a resultant in the horizontal. I like to just use R for resultant and an arrow on top to show it's a vector, but anybody can use different things. There isn't one rule that says you have to use this particular thing to show resultant. So my vertical resultant is 56,118,446,17. My resultant in the horizontal direction is going to be a negative. I usually assume, like maths, positive and negative on your X and positive and negative on your Y. I tend to stick to that, and then I don't get confused about which way around I'm going. So if I work this out, it's going to be negative 43,200,000. I know I'm going a bit slowly here. Minus 32,400,000. So this is going to be minus 43,200,000. Just double checking that I got that all right. You're going to have to correct me if at any point I make a mistake because it feels rather big numbers. Negative 10,800,000 newtons. This vertical is up. This value with the negative, I'm going to take away the negative now because, and the one. I'm going to take away the negative because the negative just means towards the left. Okay. Now, unfortunately, I've run out of space again. So I'm just quickly going to take away a whole bunch of my question. Okay. I know you all knew it, so it's good. And here, I'm then going to assume that I've actually got just those two components. So it's an upward force and a force towards the left. So I'm going to use Pythagoras. Okay, remember the upward force is 56, blah, blah, blah. I'm not going to write it all on the page. This is the 10, and there's my resultant. So I'm now going to use Pythagoras to work out my resultant force. Somebody actually queried after the lesson yesterday about, man, but surely those values of velocity should have had a direction. You know what? They're 100% right. They should have. But I assumed that we were working with magnitude. Now, I could assume that because I was the teacher and I was telling it. I can't assume here that the question, when it said resultant force, was talking about the magnitude of the resultant force. It probably wasn't. So we've got to work out both the resultant and the direction. So R squared is equal to X squared plus Y squared. I know some of you guys do A squared plus B squared is C squared. Same thing. Okay, so it's 56,118,446,17 squared plus 10,803 zeros squared. All right, lots to put in my calculator. 56,118,446.17 squared plus, I wish these were bank balance numbers. They're very nice and big. And then we square root the answer, and I get that the resultant is 5.618. So I'm going to make it 5.61 times 10 to the 10 newtons. And then to get my direction, I must remember that I probably could do bearing. I could talk about relative to the vertical or the horizontal. Why are both given? Sorry, just give me a second. Sorry, there's a question from a bra saying, ma'am, I know this is a blunt question. Don't worry, we all ask blunt questions. But why are both values given for RH? Oh, okay. It's because we have a component that's up and a component that's to the side. So I had to work out the vertical component there, and then separate to that, I had to work out the horizontal component that went in the other direction. So I'm now using Pythagoras, yeah?
Sorry, I think I got a bit confused on that as well. For the RH, you said negative 4320000 minus 324000 instead of plus.
Sorry, thank you for picking that up. You see, what I did was I wrote it down as negative and did it as positive. So this is the negative direction, you're 100% correct, and this is the positive direction. So I called it a minus, but I made it a plus. Okay, and then this came out negative, but instead of leaving the negative in there, I said towards the left. So I kind of got rid of the direction here by just putting in the direction it went and making sure that it kind of matched up with my picture. All right, thank you very much, Dean. Brad, does that make sense? Sorry, sometimes when they're questions, I get a little bit lost as to what they mean if I'm not on the same wavelength. But thank you for well, I guess that was collaborating and elaborating. Okay, all right, was there another question from someone?
Sorry, ma'am.
Okay, brilliant. Yes.
For your calculation of R, when I worked it out myself, I got a different answer.
Okay, which one? Which one?
Yeah,
This
the
one.
R is equal to 5.61.
Okay,
The
that
final
value.
answer.
Okay, here,
Yes, miss.
this one.
Mm-hmm.
Okay, let me go back. I may have rounded it. Let's just quickly check.
No, that's completely different the answer I got.
All right, let me just quickly check. 56,118,446.17 squared. Guys, you're always welcome. I know we do these late at night, and my brain sometimes is not 100% here that late at night. Square root answer. Okay, I get 5.7 now. I apologize. Thank you. Let's go back and change that value. Okay. This is why you guys are so important to check that what I put into my calculator is what it's supposed to give me out. Is that more like what you got?
Yes, ma'am.
Yay, thank you. Please always ask, because I have to trust, because I'm in a bit of a hurry, I have to just trust that my calculator is right. Normally in a test or exam, I would double check my own calculations. But if I were to double check every calculation, it would take a much longer time. So I usually work on the basis that if nobody corrects me, then I'm right. Okay, so you guys are my calculator double check. All right. So we need the direction here. So to do the direction, we're going to work that value of theta out. Please remember the direction always starts from the bottom of the vector, so the tail towards the head. And here for bearing, we go around from 0 degrees all the way around, usually to 360, but here we're going to actually stop before then. So we're going to say tan of theta is equal to opposite, which is a big value, 10,800,000 divided by 56,118,446,17. Now I know some of you may not have used tan, you may have used this value of R that you calculated and use sine or cos, but I usually recommend against that. If this value is wrong, then your direction will also be wrong. Whereas if you use sine and cos, you'll still get the correct value as long as everything else obviously was correct. So I'm doing shift tan or second function tan, 10,800,000, I hope I've got enough zeros. Yeah, that looks right. Divided by 56,118,446.17. And I get an answer that the angle theta is 10,89 degrees. So once I've worked that out, I can then go and say that my bearing would be 360 minus this. So my bearing is going to be 349. Therefore, I can say that the resultant, or even, remember the question was, what's the resultant force? So you could even go and change this now to say, oh gosh, we could do this so many different ways. F net, FE net, because it's electrostatic, you choose. So it's 57,148,228,32 newtons, bearing 349,11 degrees. There are other ways to describe the direction that it goes in, which we know is somewhere there, but this is probably the safest way, unless you're going to go and say, I don't know, which was at 10.89 degrees anti-clockwise from the positive y-axis. That always sounds a little bit mechanical for me. All right, so I'm now going to stop sharing, quickly take a screenshot if you needed to. Hopefully we've now got the right answer. If any of you disagree with my answer, now is the best time to talk. Okay, so I'm going to presume I can stop sharing. Now, yeah, do you disagree with me?
Oh, no, I don't disagree. I just wanted to ask quickly, when you just said 360 minus we got 4
Yes.
theta, right? Okay, and then you just said that's okay. Just
Yes.
double check.
That is, just give me a second. It's because if you remember, your bearing assumes that straight up is 0 degrees. And then everything around from that goes clockwise from 0 degrees to 360 degrees. And since this little snippet stole 10.89 degrees of that angle, it'll be 360s all the way around minus the 10.89 tells me how far around to there. Okay. All right.
Thanks, ma'am.
So my more important question was, who got this right on their own? More right than me, at least. Who got it right? Thumbs up. Okay, well done. Fantastic. Okay, so some of you did. That's a good sign. Okay, and those of you who didn't, did you figure out where you went wrong? Okay, brilliant. Now, these kind of questions are where electrostatics get tricky, because electrostatics suddenly can bring in anything where you've got to do calculations on forces, and that makes your life quite a lot harder. So what you've got to do, if you break this down to a simple question, is this question wasn't that hard. It involved you doing Coulomb's law twice. Then it involved you looking at what you knew about an equilateral triangle, also to get the 5 centimeters that you needed for both of the distances. It involved you looking at basic force vectors and working out a resultant, and then working out a bearing. Every one of those tools on their own, you probably already should be able to do. Does everyone agree? Are those tools things that you don't yet know? You know how to do all of those. So where physics becomes difficult isn't that you can't do the steps. It's that you've got to see how all of the steps fit together with each other to be able to solve the problem. That's where it gets tricky. When I was your age, I had an amazing extra lesson teacher, and he used to always have a famous quote that he said, which is, how do you eat an elephant? And the answer was in small bites. And the reason you ate an elephant in small bites is that if you break down any big question into the simple questions, all of you actually know how to do all of the individual pieces. The problem is the planning and the linking everything together. All right, can I give you one more question for today? Probably more than one, but at least one. There's one more that I really plan to get to, and after that I'm going to have to start winging it a little bit. But one more question. Okay, now this is an interesting question. Okay, so I want you to listen very carefully to my wording, because I'm not writing it down. I'm going to tell you that we have a charge Q1. We've got 2 different scenarios. Badly. We've got 2 different scenarios. I need to start learning that I just can't draw straight lines. Okay, so in both situations, Q1 is identically the same. Okay, and then we've got a situation where we put 2 different charges here. So this is going to be Q2 and Q2, and this distance, once again, same problem. This distance here is D, from the center of one till the center of the next. You can assume whenever I'm drawing these that I mean them to go all the way. I'm just not actually drawing it the whole way. So this is the center of one till the center of next. Both of those are D, okay? But now I'm telling you something different here, okay? I lie, I shouldn't have called these both Q1 and Q2. I'm going to call this Q2, or this, let's just call it Q. And this one is twice as big. Okay, so we're going to be discussing this charge, which we could call Q or A, I guess, and this charge, which I'll call B now, just to make it easy. So I'm going to repeat again. Both of the charges over here have the same charge. Both of the distances are the same. Q, A and B are the same size, but B has got twice the charge that A has. So you can see here that QA, and this is twice the charge of QA. So let's just give you an example. If this were 3 millicoulombs, this would be 6 millicoulombs. And we can even make it nice and easy and put a charge on here so that you understand the question. So for all of the questions that I'm about to ask you, the options that you can give, A says that A is bigger. A is the top scenario. Okay. The second option says that B is bigger. And the third one says that both are the same. And I want you to think very hard. So the first question that I would like to know is which of the charges, A or B, experiences a larger electric field strength or electric field at the point. They're the same concepts. So your electric field strength is your value E. Okay, so I'm going to ask you, I'm going to quickly just now scroll across that you can all answer, but take a screenshot if you need to. Have a good think on this. Which one of those two is larger? Okay, so I'm now going to quickly stop sharing and I'm going to ask you for your input. Okay, so let's see everybody. Who said that A was larger? Thumbs up if you think A is larger. You're welcome to speak up if you need to. Anyone? A is larger. Okay, let's move on to the next one. Who says that B is larger? Oh my goodness, no one's committing. B is larger. Okay, more of you. Who says that the answer is C, they're both the same? Okay, now we had a little bit of overlapping of thumbs there. So they're both the same. I think some of you did double thumbs. Yay. Okay, either way, you'll know whether you got it right or not and for the right reasons. So the correct answer here, dun, 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 is that they're actually both the same. If we look at the equation, which says that the electric field strength is equal to KQ over R squared, and you remember Q is the charge creating the field, you will realize that both of these charges here are experiencing the field. So these would be what we regard as being our little q's, okay? So both of them have the same charge creating the field. Both points are equidistant away from the charge creating the field. So therefore, from that, we should see that the answer is that both of them are the same. All right, I need to just quickly erase my answer. All right, everybody happy with that as an answer? Let me just quickly stop sharing. Okay, does that make sense to you? Who got caught up by the thing because the one was bigger than the other? Okay, it's quite a common thing. They love asking you questions. As teachers, we ask you questions that we know you're going to trip over because we just want to check if you're listening. Okay, actually, it's not really that we want to check if you're listening. We want to check if everybody's following. We don't do it all the time, so please don't make tricks where there aren't. But at the same time, you need to be aware of the fact that sometimes teachers get a bit of a kick out of making questions slightly more challenging. It's a good thing. It challenges you, and I guess it challenges us too. All right, now comes the next question, and now's where I'm going to see if you've been paying attention. Okay. I now want to know which one of A or B experiences a larger force. And that would be an electrostatic force, okay? So I want you to quickly have a look at this, and your options once again are A or B or both are the same. Okay, you should already have a screenshot of this, and this question shouldn't take you that long to get through. Okay, so I'm going to stop sharing already. Okay, who says that the answer is A? Who says that the answer is B? Okay, I'm going to wait for all of your thumbs to go away first. Otherwise, I ask questions and I don't know who's still there. Oh, well, judging from this, like the only two of you that could go for the answer of C. Does anyone think that the answer is C? Okay, well done, everybody. The answer is B. And the reason that the answer is B, if we go back to it here, is that we already know that both of them have the same electric field strength. Well, technically it should be electric field strength here and here. So since they have the same electric field strength, our equation is going to be E is equal to F over Q, okay? Which means that F is equal to EQ. When things are constant, I like to just draw a horizontal arrow to say stays the same. So that means that if the charge is bigger, the force will be bigger, and this is twice as big a charge, so therefore it will have twice as large a force acting on it. Okay, so those two questions happen to be the two that I came across today that I thought, there's an interesting question to get you guys thinking. Just so you know, if you're planning on doing medicine next year, those are your questions you're going to get in your physics notes. All right, so we've got a little bit of time, and I don't want to keep everybody too long because I know maths went on a little bit overtime today, but can I quickly have a show of hands? We've done a hard question on Coulomb's law, and we've done a multiple choice thinking question on electric field strengths. Who is game for one more question on electric field strengths and calculating resultant field strengths? Thumbs up if you're keen. All right. So what I'm going to do, to be fair, because I know we're going a little bit over time, if you need to leave, please feel free to leave. No, I don't take any offense whatsoever, but I'd like to do a little bit of a tricky question. Please note, though, I'm warning you already, I am making this question up, which means that I may very well turn around later and go, ooh, wait, need to change the values. Okay, but I shouldn't. Okay, so let's quickly go into this. So we're doing one of their favorite types of questions, and that's where you've got two charges. Okay, now we're going to make these two charges. Both of them are going to have the same charge. So let's make this plus 6 nanocoulombs and positive. I said they both had to be positive 14 nanocoulombs. And these two charges are placed a distance of 20 centimeters apart. And the question says, I'm going to learn for myself, and I'm going to draw in my little line here so that I don't try and draw it myself and get it all messed. There's a direct line between the two, and you're told that the distance between the two is 20 centimeters, and you're told that there's a position somewhere on here where the electric field is equal to 0 newtons per coulomb. Alternatively, they could say that there's a point in between them where the forces in both directions are equal. Okay, but I'm going to specifically tell you that there's a specific position between these two. Okay, quite often they're nice and they'll tell you that this is the distance x, and then your question will be to calculate the distance x. Okay, I'm going to give you just a second to quickly take a screenshot if you need to of this. Okay, everybody got that? And then I'm going to quickly stop sharing and we're going to discuss it. Does anyone have any idea what we're going to do first?
Yeah.
Okay, yes, Brannon, what will we do? What would you do?
I would first both put them into the E equals KQ over R squared, and then make them equal each other, and then solve for R. Okay,
now I've got one question. The one distance that you're going to use is x. What is the other distance that you're going to use? So you've got x is between the first charge and the position. What is the other distance going to be? Yes, Alex?
20 minus x.
Okay, welcome back. Did you have a good supper?
Yes.
Okay, wonderful. So let's carry on here. So what you would do is you'd have x here, and then because you know that this is 20, Alex, actually, what was your answer? What did you say? Just repeat it.
Minus x.
Just repeat it one more time. Sorry, I missed that again.
20 minus x.
Okay, now I'm going to tell you you're wrong, because this must be in meters. So it's actually going to be 0.2 minus
Minus.
x. Don't worry, close. But the
Cool.
problem is sometimes we're so quick to jump in that people know what they're doing and they do exactly what you've just done. So I, in fact, said yes to it, and then I thought, wait, no, not that one. Okay, so what was mentioned is completely correct. You're going to appreciate that the electric field in both directions is equal. And in fact, this one is going to be, if we were to call this A and B, if you put a positive here, it would be repelled by B in this direction. So that would be the electric field due to B. And in this direction, it would be the electric field due to A, because both of them are positive and we get repelled away. So I'm going to ask at this point, if everybody's good with it, I'm going to pause and I'm going to give you a chance to calculate X. Unlike the last time, because we don't have weird, funny vectors coming in, I am not going to stop and then show you the last steps. I'm going to work right the way till the end. You work right the way till the end, and then we'll compare our answers. All right. I'm pausing my share now. Please go for it. Sorry, I'm facing the first world problem of moving my screen up so that everything's in one place. There we go. Is everybody nearly done? I've made any mistakes here. I think you're all hoping the same thing. Okay, can I see if anyone's yet finished? Okay, good. Don't worry, I don't have to, I'm not racing you. I'm just checking. Looks like you're getting there. Okay, I'm having a problem here because I'm getting answers that don't make sense. Has anyone got an answer that does make sense?
I'm
On one
getting
side,
wondering.
and it comes to my fault. And it always
So-
gets
So has anybody got an answer that does make sense?
I got 0.16. I don't know if
0.16.
that's
That
Yeah.
sounds like a valid answer. Okay.
I
Now
got-
I'm already
I
telling you.
got
Yeah. Okay, I can't hear everybody at the
I
same
got
time.
0,079.
Okay. So
I
what
got
I'm
0,079.
Okay, what I'm going to do is I'm going to show you my screen, and when I'm going to play where did I make a mistake, because I've been through it twice and I can't find my mistake, and I hate it when that can't happen. When that happens, I'm sure most of you can relate to the same thing where you get to the end and you're like, it says there's no answer, but I've got a point between two positives. It's being repelled. It's got to get to a point where they must cancel out. And I'm just worried that maybe what I did was the sign wrong. So maybe that's where I've gone wrong. Let's have a look at this. Okay, so I'm going to share my screen with everybody. So can I please check? You're just going to respond at each point. Did everybody get this value for the electric field due to A? Yes. Okay. And did everybody get this for the electric field due to B? Okay, if you didn't, please speak up now. Now, what I think I may have done wrong is if you look here, I said the electric field at A plus the electric field at B equals 0. And I would have then said, well, the fields act in opposite directions. So therefore, I could say that this magnitude equaled that magnitude, which I did here. So here I've got 9 times 10 to the 9 times 6 times 10 to the negative 6 over x squared, because x was the distance between A and that value, and those match up. And here I've got the same value over here. So that bit's fine. I don't like doing big calculations. So anything that's the same on both sides, I made it disappear. Okay, so this is basically like saying forces to the left equal forces to the right. Here I'm saying the two forces must be equal in terms of repulsion, or the force per unit this charge that we don't have a charge at. So then what I did was I was left with 6 over x squared, and here I was left with 14, and then I multiplied this out. It would be 0.2 minus x times 0.2 minus x. I'm certain someone's about to tell me what I did wrong. Yay! Okay, what did I do? Oh, you guys are fantastic. I shouldn't do things in my head. How? Thank you. I knew it wouldn't be. I kept looking at it going, this has got to be easy. Okay, so my problem was that I assumed that 0.2 squared was 0.4, not 0.04. So that becomes 0.04, that becomes 0.04, 0.04, 0.04. And then if that get times by 6, sorry, I kept doing this and I kept going, no, why is it not working? Okay, well done everybody for picking up my mistake. I'm going to take off that last line now.
I think for your trinomial, you made a mistake again because it's supposed to be 0,04 minus 0,4x plus x squared.
Okay, just give me a second. So then that was 0,04, that was 0,04.
No, that's negative 0,4x.
Which one?
For the middle.
Here.
Yes.
Oh yes, because it's just being multiplied. Okay, so that's where I went wrong as well. Wow, special. So this is going to be 0,4. There we go. Okay, so my problem was that I decided I was way too smart to do FOIL. Okay, so if I then went and multiplied that out, 0,02 times 0,2 times 0,2 is 0,04. That gives me negative 0,2. That gives me negative 0,2. Yay. Okay, thank you. I knew I was making a silly mistake and it wasn't giving me the right answer. There we go. So carrying on from here, we then would have the 6 being multiplied by that. So that's 0,24 minus 2,4x plus 6x squared is equal to 14x squared. Then we get everything over to one side. So we're going to have 0 is equal to the 14 minus the 6 is the 8x squared plus 2,4x plus minus 0,24. And I knew that I was getting it wrong because there's no way that you can't get an answer with this particular question. There's got to be a point in the middle. Okay, so I'm then going to quickly just stick this into my calculator. Sorry, the one that can do this. It's on the wrong calculator. So that's going to be 8, 2.4, and negative 0.24. And when I do that, no, why am I getting 2 wrong answers still? Did I do something wrong? Am I just really special today? That becomes positive, that becomes negative. Okay, nobody's yet commenting. So I've got an 8 for my A value. I've got a 2,4 for my B value. And I've got a negative 0,24 for my C value. I still get 2 imaginary answers. All right, who got this far? Can I double check? Did anyone get to that point?
Yes, ma'am.
I had a different trinomial.
Okay, so can I just go back a step? Sorry, this is bad maths, but we got to go there. Did everybody get to this answer? Okay, because that should be the key thing then when we just multiplied out here. And if I multiplied that up there, I think I'm still good. And that up there, someone else has found our next error. Also a different trinomial. So where's, okay, so Zoe, just quickly check with me. Where was your different trinomial? Zoe, are you there? You can unmute yourself and speak up.
Sorry, I don't know what, I didn't get 6 and 14. I don't know why.
Okay, because multiplying that by that and that by that, I guess you could have got something bigger if you left in your 9 times 10 to the 9 and all the rest of that.
Yeah, so I left all of that in.
Okay.
So then I got 54 over x squared
All right.
is equal to 126.
Okay, so somebody
over-
else has got the same as you. Now my question is, okay, Sam's
Yeah.
also got the same answer. Yay, you guys are all getting the right answer. But the question I've got to ask is, why is mine wrong? Because well,
Ma'am.
I guess here we can
Ma'am.
cancel those. Yes, yes. Sorry, someone was speaking. Yes.
So what I did in the very beginning, so like I got the same answers with the 54 and the 126, but I'd worked out I worked them out separately, and I hadn't put them into, oh well, like you did, the EA and the EB. But then I didn't say EA plus EB equals 0. I made because they're acting in opposite directions, I made the one a positive and one a negative.
Negative and
so I said EA minus EB equals 0. And then, oh, well, then you get the same thing. Oh, never mind.
That's why I'm saying is, I think
Ma'am.
even if we went and times everything by 9, it should be the same. So my question is, where did I make a mistake? I know it's making it very tricky and it gets a little bit tiring on this. I always find that with some of these, it gets to the point where you're like, this is maths. Okay. And I'd like to just give all of you guys a little bit of a hint before we waste too much longer on the solving the silly
I think
quadratic.
I found it.
Yes. Okay. Quickly, Alex, what do you think I did wrong?
You said that EA plus EB equals 0, and then you take them across, but you don't put a negative.
Well, you see, the thing was they're
Ma'am,
acting
I think
in
I know, but
directions.
I don't know.
Yeah, let's try. It's okay. I think sometimes with things like this, it's where you have your discussions or your arguments about it. I promise you I will figure out the end of this, and then I'll be like, damn, that's what you did. Okay. But before we go any further,
No, that makes sense.
What?
No, I brainwave. Don't listen to me.
Okay, don't stress. This is where we have decent scientific and physics discussions. One of the
Ma'am,
things that I wanted, for
Ma'am,
Freya?
if you type in your trinomial that you have in the calculator, it gives you the right answer, 0.08.
Yeah, ma'am, because if you worked out with the 54 and the 126, you get the same trinomial. If you divide our trinomial by 9, you get your trinomial. So
My calculator is not
you do get
listening
the right
to me.
answer, I think.
So if I put in, because my value of A is 8, definitely is. My value of B is 2.4. It just doesn't like me. It's adamant that it's giving me 2 imaginary numbers. Okay.
Try pressing S to D.
Yeah? No. Sorry, when I say it's giving me, no, it's not the surds to decimals. It's giving me the square root of negative numbers and imaginary things. I think this calculator needs to be hit somewhere. Okay, so if you guys are able to stick mine into the calculator, thanks, you guys are giving me such helpful maths tips. I love it. Okay, so let's just quickly check. Not negative 0.24, it's positive 2.4. Not if I move it across. B, where are we? Okay, I'm not quite certain where the B value is. Here, this B value, when it goes across.
It's that one that she's talking about.
But it would have been a negative here, and it goes positive when it goes. Okay, so if you guys are able to get this on your calculator, it might just be that mine very strangely is not listening, which I've never heard of before. But hey, maybe it's time for this calculator to wake up. But what I was going to say that's probably more important than this is we're all going to hit this question at some point in an exam where we're sure we've got the right idea and we know we've got it and we know there's something wrong, but we can't find it. And this is probably a good place to give you a lesson. Do you know what the answer, how many marks I'm missing out on in this question? Does anyone know? I'm going to stop sharing. Does anyone know how many marks? If this was out of 7 or 8 marks, how many marks have I lost? If I stop right now.
1.
1. The final answer mark. So my recommendation is, as frustrating as it is, I would very much try then at that point to just breathe in and out and go, it's 1 mark and leave it. The reason that we do this is where the government is, well, the government, the Department of Education, etc., don't want to put too much weighting on your maths ability in a science test. So when it comes to your science, we're going to give you marks for your formulas, your substitution, your manipulation of data. But from when you substitute everything in until your final answer, there's only 1 mark per answer. And here, since there's only 1 answer, that's what you'd get. I'm going to try this one last time because I'm adamant that I'm going to make this work because I don't usually have to give up. So I've got 8. Pretty sure I did push 8. Yes, I did. I've got 2.4 and I've got negative 0.24, negative 0.24. No, it's still adamant. Okay, so what answer did the rest of you get for this when you solved? You got that x was equal to? Anyone speak up?
8 centimeters.
8 on the dot.
Centimeters.
0,079.
0,079 meters. So is that exactly the value that you got on your calculator?
7.9 centimeters.
Okay, so that would give us 7,9 centimeters. Please do a last little check here for yourself and always make sure that this answer makes sense. If this value that you get here is bigger than 20 centimeters, it's physically impossible. So always check that your answer works out. Now I've got to go and try and work out why my calculator is not working, because calculators should work. Okay, so did anyone else get 0,077? Okay, I don't know if anyone did. Sorry, Abra. But you know what? At least your calculator didn't tell you that the answer, mine's very special, was -3 plus square root of 21 over 20. I think this calculator's been doing funny things. So just quickly, Danny, you've asked a question. How many marks will the first question be worth? I presume by the first question you're referring to the very first one that we did. And I quickly clear one, I think. So I'd say that there's 1 mark for the formula F is equal to K Q1 Q2 over R squared. 1 mark for subbing in for each of the 2 values. 1 mark for working out for resolving the one into its components and or for adding them together and to get the resultant. 1 mark for using Pythagoras, 1 mark for the answer, 1 mark for using tan. Tan may or may not come with the substitution marks. I'm going to put it in as there, and then 1 mark for the answer. 1, 2, 3, 4, 5, 6, 7, 8, between 8 and 10. Okay, I think 8 here is very realistic, but depending on how leniently they're marking and where they're giving the marks, it's between 8 and 10 marks for all of the different steps that you'd need to do. All right. Okay. Ladies and gentlemen, in spite of my calculator really not working, and I have no idea why it's not working, maybe it's because it hasn't seen the sun today. I'll give it the benefit of the doubt that it hasn't seen the sun. Okay, can I quickly ask who found this lesson today to be beneficial? Okay, fantastic. So what I'm going to be doing, and I don't know if we're necessarily going to be doing it on Mondays or Wednesdays. I'm keen on Mondays because I think it just gets my week flowing a little bit, is that I would like very much that at the end of every week, depending on who got the best results for practicing up until the Sunday on whichever section we're doing, that you get invited to a session like this where we kind of go into a little bit more detail with the harder questions. My assumption is that if you've been practicing that much, you should understand the work that we're doing. Did anyone find the work that we were doing here too challenging? You're allowed to speak up. I know it's a little bit of a step up, but hopefully with the amount of practice that you all did, I mean, there were 12 people on this group who got 100% mastery. And that, I don't know if you know it, but it means that the Siavula computer is betting that you will get it right every time. They're that confident in you. So it's a statistical thing that they're willing to bet that you know your stuff. So I kind of decided that based on that, you'd be able to do it. Okay, so please make sure that you do lots of practice in preparation for the next section.